moving forward in the catcher game, to add in a way that we could lose, we're going to look at two options. One of those is we will have additional objects that are falling, and then those objects will be hazardous instead of point scoring. And then we're also going to look at how we can have a countdown timer. So we give the player a certain window of time in which to achieve the necessary winning score. So both of these are ways that we can go about achieving this. So to have a second set of objects that are falling, we could make another class, and that class would be virtually identical to this one. It would have XY width and height, it would have speed, doesn't really need a color per se, but it's going to have all the same methods of display, caught, reset, update. So it has all those things that are already present inside the drop. And when we look at that, it makes us think that, maybe there's a way we can do it without duplicating all of that code, because then we would also need a second timer. We would have our drop timer, then we would have our hazardous drop timer, and we would be duplicating all of these variables. So that's not going to be a great way to go about doing it if we're just having everything duplicated. We certainly can, it would work, and it is one possible solution. So you would just duplicate everything related to the drops, have a duplicate class, and then reference that. Instead of drop, it would be bad drop, and then bad drops. And so there's, you could just duplicate the whole thing, swap out which image it's showing, and you are in the running. So that's one way that we can go about doing it. Another way that we can go about doing it is we can modify the drop class itself so that the drop class is composed of, it has different types of drops all contained within the drop class, because the only thing that's really different once we declare a type is how that drop is displayed. We could also perhaps give those drops a different speed as well, so that they have some variance, so they behave a little bit differently than the other ones. So we'll look at how we can explore these. To do this, we're going to add an additional property to the drop class. So inside the drop class, I'm adding in a property, and it will be of type string, and my property will be simply called type. And then when we create a drop, we're going to pass in a value, and the value we pass in will be a string, and it will be the drop type. So in the catcher, when we create new drops, we will pass in a value of what kind of drop we want it to be. So that we will, in this case, we're going to set up two different kinds of drops, because that's what we have for graphics, and that's what we'll look for in the behavior, but we could do more. And when we do that, we will just pass in a word here to reference what kind of drop we're working with. So now, to do that, we just simply specify, and I'll just separate this out so it's easier to find. Type is going to be equal to drop type. So when I have a function or a method and I pass a value into it, so in this case it's looking for a string, and the string will pass in, let's just say we pass in medkit as our type of drop. So now we're going to pass that in, and now it knows it. So we can access it in our main program because we've now added on this property. So the same way that if we look at under intersect, we're working with objects where we're referencing their x, their y, their width, their height, so we can access those properties of the object. We're also going to be able to access what type of drop it is we've created. So then we can say if type is equal to medkit, couple curlies, close it out, else if type is equal to COVID, couple curlies, close it out. Now we could have an else statement in here where we would have, or another else if. So if we had a third type of drop, we could populate it in here as well. Now, when we're passing this in on what type of drop that we are going to be showing, then we're going to be able to, in our display method, we're going to be referencing what image we want to show here as well. So we will also need to work with that. So we won't reference, like here, where we're referencing the image on it. We have our drop image. And our COVID image right there. So now let's populate that. Will be equal to load image data / COVID.png. So now that's been populated there as well. Now if we go back into the drop here, now we're passing in now. I mean, we could even just pass in the image and then we check what type of image it is. So if we change this from string to image, but I'm going to just leave it like this right now. And we'll just make a note there. So if it's a med kit, then it's going to use, my image reference will be drop image. And it was spelled out. Drop image. Else is going to be COVID image. And just verifying my naming, to making sure my names are correct as I'm doing it, because we have to make sure we're keeping track of that. So right now, if we do nothing else, we're in good shape. So we said the height and width were 28 for the drop image, but the width is going to be equal to 50, and the height is going to be equal to 50 if it's the COVID, because the COVID image was bigger. We could even set different speeds for the drop and everything, so they could have a different speed value, all of that. But by doing it this way, we don't have to change anything except in display, where we then say we want to see the image ref referencing which image we're working with here. So if we run this right now, let's see if we have any change. Okay, we got all the med kits falling, good. If we change this now to COVID, so we pass in COVID instead of med kit, we'll see that this time, let's figure out where it went. So if our type is COVID, I undid something momentarily, and apparently that undid that. So there we can see it's now COVID drops falling instead. So we know that we can make it work this way. We just pass in what we want it to be, medkit or COVID, and it works. Now, what we can do is we can say, okay, right now I have 10 drops in my project. I could certainly have 20 drops, 100 drops, which if you're saying you have to catch a certain number of drops in a certain window of time, and the drops, once they're caught, they stop being part of the game, then you better make sure you have enough drops in play. And that would become an issue with the timer. But right now what we're going to do is set it up so that we are able to create a certain percentage of the drops are going to be med kit, and a certain percentage of the drops will be COVID. And the way that we can do that is we will use the fun little math operation, and it's called Modulo, and I'm going to type it out, and then we'll go look it up and see exactly how this works. So right now, if I do it like this, and let's add closing curly over here. So if I say I percent 2. So this is the math operation. It's the Modulus Math operation. And what it does is that allows us to use the remainder instead of the number we would get. And we don't. So what we're doing is we're doing division. And we don't care about how many times something goes into it. All we care about is what is left over when we have completed that math operation. So if you ever thought, why did I have to learn long division and remainders when I was in grade school? What purpose would it serve? When would I ever use such a thing? This is that time. A friend of mine who is CFO at a company was complaining when his child had to learn long division with remainders. He said, nobody uses remainders. We only use decimal points. What's the purpose of that? I said, oh, I use them. And we had a discussion, and he still felt, well, this is a niche situation, so it's not something that we would use every day. But it is something that's used more often than you would expect in programming. So if we look at the Modulus Math operation, or modulo here, what we see some examples. So if we say 5 modulus 4, so we're essentially saying take 5, divide it by 4. 4 goes into 5 one time, and we have a remainder of 1. So that means we get the 1 left over. 125 divided by 100, 100 goes into it one time, and there is 25 left over. So B would now be equal to 25. 285.5 divided by 140, we can see that it's 140, it goes in there 2 times, but it gives us a remainder of 5.5. So the real advantage is when we use it during a loop, when we're going through a for loop, like what we're going to do in the code here, because I is going to cycle through here. So each time we go through the loop, I is going to change. So it starts out at 0. 0 divided by 2 is going to then give me a value of 0, because 0 divided by 2, well, 2 goes into 0 times, and we have nothing left over. 1 divided by 2, which if we just say 1 divided by 2, we go, oh, well, that's 1/2 or 0.5. But if we are using a remainder, we say 1 divided by 2, well, 2 goes into it 0 times, we have a remainder of 1. And then I becomes 2. 2 divided by 2 goes into it 1 time, remainder of 0. 3 divided by 2, 2 goes into it 1 time with a remainder of 1. Therefore, you can start to see a pattern. 4 divided by 2 goes into it 2 times, remainder of 0. So we've gotten values using this operation of 0, 1, 0, 1, 0, 1, 0, 1. So what we're able to do is we're able to then figure out what type of frequency. So if I want half of my drops to be COVID and half to be med kits, this is going to give it to me, because I say if I divided by 2, if that remainder of that operation is equal to 0. So the first drop it makes is going to be a med kit. Then our next drop it's going to make, so drops I, and you could copy paste this, is equal to a new drop, and this time it will be COVID. So out of my 10 drops, the first one will be a med kit, second one will be COVID, third one med kit, fourth one COVID. So we're going to get 5 of each running it this way. And if I look, we can see that now I have my drops, and if I count them on screen, that's exactly how many I have. Now, currently, I'm getting positive scores for catching either one, and we don't want that. We want the COVID to be toxic. We'll make the COVID have a high fatality rate. So you catch one COVID, it's game over. Could also make it you catch COVID, your score goes down. So if your objective in the game is to earn a certain score, you can make the score go up or down as part of it. Now, if I were to change this, and let's go to 100 drops here, this would be 50-50. But if I wanted it to be 2/3, 1/3, just change this to a 3. So remember, 0 divided by 3, 0 remainder of 0. 1 divided by 3 is going to be 0 remainder of 1. 2 divided by 3, 0 with a remainder of 2. 3 divided by 3 is 1 with a remainder of 0. So we got 0, 1, 2. And then it's going to repeat 0, 1, 2, 0, 1, 2. So that means 2/3 of the options will not be equal to 0. So this means this would be a toxic game. 2/3 would be COVID, 1/3 would be medkit. So I could either change the order there, or we could change it so that zeros give us COVID, the non-zero options give us medkit. So either way works as you go through it. So this is going to be a toxic game because it's going to be a lot of COVID and very few medkits, which I think almost makes the game a little bit more fun because now it's harder to win because now we have a high disease rate. Oh wait, except I can win by scoring on the COVIDs. Well, that's disappointing. So let's fix that. So I think having more COVIDs than medkits makes the game a little bit more challenging. So then that bodes well. Now if I go and look in my game here, and I'm checking to see, hey, if I've collided with a drop here, what we want to know is the drop that I hit toxic or not? And then when it's a good drop, a med kit will make our score go up. But when we catch COVID, we are going to immediately change the game state to lose. We could also just make the score go down, especially if we have a timer on the game. That would be part of it. And maybe if you're doing it that way, you could make it so if you can catch the COVID more than one time, you don't catch them, so you hit it, and then it really is... No, you still need caught, though, because it needs to move it out of the way. Otherwise, you'll rack up your positive or negative score very quickly. So if we have caught a drop, then we put an if inside of this and say if drops square brackets I dot type is equal to, and right now we're going to look for medkit. So if it's a medkit, we're going to do all of that, else this means we lost here. Just put a comment in there. Comment in there. So now I can go and take this stuff right here, and we'll just paste that in. And now if we catch COVID, game state will be equal to lose. So now let's see, that means if I just catch one COVID, that's bad. Medkit, good, medkit, COVID, you're a loser. We could update the messages now, because now that we have a bit of a theme for the game, and it sure would be nice if these graphics on the title screen and on the win and lose screen match the rest of the gameplay graphics, so we had a consistency and a theme, and it was part of a whole package, so it goes together. Because just using the flat graphics here, but then having the game here, let's see, die, I can die right away, or 1, 2, 3, hey look, it worked. All right, so to recap here, we nested an if inside of our if. So our internal if checks to see what type of object was caught. So first we find out if we caught an object, because there's no point in continuing on that drop. If we didn't catch that drop, we don't need to look and determine, hey, was it medkit or was it, we don't care. We only care when we catch it. And then when we have caught it, then we do it. Now, another advantage of having done it this way is that we didn't need to write a second intersect method. Because if we had an additional method or item, so if we had our bad drop and our normal drop, well, because we have to pass and tell it what type of object we're checking for, we would need a second intersect method written out that would be pretty much identical, except it would just say, bad drop, or in this, or whatever COVID drop, or whatever, you choose to call it in your project. So having done it this way, by just setting a type property on our drop, we're doing the least amount of code repetition, because we're not doing multiple loops through all of the good drops, all of the bad drops, which, we're going through all the drops anyway, but we don't have it as two separate loop functions. We're not using multiple loops to generate all the drops. We're not having an additional class that is virtually identical except for what image is being displayed and its sizes. So it makes sense to just do it through the type method versus just duplicating everything. But that is, and in some situations, the better way to go. Other times, what we do is we build a kind of a generic drop class, and then we extend it, and we would have a good drop class and a bad drop class that are both extensions of the main one, where they would inherit all of the main generic drop properties and methods, but then it would have their customized information contained in it. So that would the only thing be different within that object class. So that'd be another way we could do it. But doing kind of extensions of classes in processing doesn't work particularly well or easily. So that's why we're not following that method. Another method we can set up for controlling whether we win and lose the game is going to be a countdown timer. So we currently have the drop timer operating in the game, and now we're going to add in an additional timer, and this is going to be a countdown timer. So I'll just go up here. So we have our countdown timer. And we're also going to need to keep track of the current time so that we can display that on our screen. So going into setup, we have lots of places that we can put it. We'll just put it after this timer right here. And when we add this to our project, current time, we'll just set it at 5 seconds. You can modify the time for your game. And then our countdown timer will be a new timer, and we will pass in 1000 milliseconds as the timer interval. So 1000 is 1 second. So because we're trying to make our timer operate on seconds, it doesn't make sense to set it at anything other than 1000 milliseconds or 1 second. So back in the game loop, we'll go into our timer management section. And probably should be adding more comments to our code as we do this. Now this timer, what we're going to do as we put this in is we will say if count down timer is complete. Notice how it looks pretty much the same as the other one because we're managing the same kind of thing. So now if, well actually I had looked at the previous one and wanted to just keep repeating what was there. So then we will subtract from the current time, And then if the current time is greater than 0, then what we want to do is tell the countdown timer to start over again. So it resets itself. But if the timer is done, so current time is not greater than 0, meaning current time is 0, we'll set the game state equal to lose. Now, to continue this, so that just checking my curly braces to make sure I'm not typing in the wrong spot. So if I click on this curly brace, I see how it highlights the one up here, so I know that that is its partner. So I want to be outside of that. Then I want to put some text on screen. The text I want to put on screen will be time, colon, space, close quote, plus, and then we will display the current time at 50,100. So that will now put it up in the top left corner. It has the same kind of position as the score text, which is at 50/50, but this is now down 50 pixels from that. One other thing we will want to do is just to make sure that we specify the colors so that we don't have any other items, because colors, whatever the last color is specified, it will stay that way for any objects that are drawn or painted on screen until we have a new statement telling us what the color is. So now if we give this a quick go, 4, 3, 2, 1, okay, we lost. Oh, and if I look at the timer, we can see how, wow, time's really going. So time is continuing to happen. And that makes sense, because once we go to lose, we're there. But what we never did is reset our current time. So by resetting the current time, now I can see where we get to play the game. Now, if you were watching, when it runs, you'll see, it goes here, we said our time should start at 5, yet it keeps showing at 4. And part of that is we're never explicitly telling the countdown timer to start as part of it, and that's something that we need to put into it. So if we go into reset game and say countdown timer start, that now if we watch, okay, 4, 3, 2, 1, I lost. But now this time it started at 5. So that's better. What that means is we need to go look in the title state here and add in that same statement, countdown timer.start. And then that starts it. And what would also, when we look at this, when it comes up on screen, we kind of see how it's kind of popping on. The timing of it seems a little off, that I wonder if we might be able to put it down with other text down here. So our UI elements here, updating our UI. And then we don't need to repeat that. So UI is our user interface. So we're updating our user interface information. And now it shows up on screen with the other part of it. We don't get that kind of little flash as it shows up on screen. So that's better. I think we don't need to be down 100, maybe 80. Let's see. That looks a little, yeah, that tightens them up a little bit. That looks a little better. So that's good. So we've added in a timer. The timer, when the timer goes to 0, we lose the game. If we get enough score, we win. If we get hit by COVID, we lose. So we've been able to find a couple of different ways to go about winning and losing within our game. Now, you don't have to make things sudden death. You could just make it play until you do lose, so there is no kind of explicit win or lose. That is another strategy or style of building a game. A lot of possibilities, and your unique solution is going to be the best one.